What's up everybody? So in today's video we are going to talk about binary trees. So binary trees are data structures which are based on the fact that each node of a binary tree can have at most 2 children. So let's check what it means. So first of all, let's draw a binary tree. Imagine that you have one element, okay, you have one value that you will use from the start when you build your tree. This value is called the root node. So let's call the root node A. Okay, now let's imagine that this root node have 3 childs, okay, B, C, D. There it's a tree, okay, because you have a structure with different link nodes, but it's not a binary tree, because in a binary tree you have at most 2 children per node. Okay, so to be binary tree it has to look like this. Okay, ABC. Then let's imagine that B has 2 children, so it's gonna do D and E, and imagine that C have 2 children. There you go. There you have a binary tree. It's as simple as that. Now let's see how it works. To implement that, you can use a linked list. So I didn't make a video yet about linked lists, but I will. So very quickly, imagine that you take this tree, okay? If you want to implement, if you want to put some pseudocode, so let's take our tree. So let's imagine, I don't know if you're familiar with the idea of object, but let's imagine that each node is what we call an object. If you don't know what objects are, you can simply imagine that each element of the tree node is an independent value. Okay, it's an independent entity. So there is one important thing to understand. If you want to implement binary tree, you need to imagine then that all the nodes which are located at the very end of the tree, so that's the root node, all those nodes are called leaf nodes. Okay, so those are nodes without children. So you need to imagine that when we said that there are leaf nodes, you can imagine that each leaf node has actually 2 children. Okay, I'll put n to null. Actually it's null. Okay, you can imagine that each leaf node has 2 children, so I'll just put an n. Okay, so n. Okay, one last thing, I said when I defined a binary tree that to be a binary tree, you needed to have a tree structure and you needed to have at most two children. But it doesn't mean that you have to get two children per node. Uh, it's actually better because it's called a full tree, but it doesn't mean we'll explain later why it's better to have this type of tree in terms of runtime. But let's just imagine that you only had, it's better just see having only one child. It will be a perfectly valid tree, binary tree. So instead you simply need to put a null value here. So that will mean that I will start to implement the null value. The null values, you create a null object there, and then just put an n like this, and then you are going to do the same for each node here, here, and the same for here and for here. Now we talked about linked list. So each element when you want to traverse, we talk about traversal. I'll make another video about traversal, but let's imagine that the only way you traverse a tree is to go from the root node, then from the left, and let's imagine that for each node, whether it's this or it's this, once you are at this node's position, you start by going to the left. Then you do the same. When you are at this position, you start going to the left, then to the right. Okay, let's imagine that for each node, the only behavior of a node is first checking at the right, then checking at the left. Let's not go into too much complexity. Let's just imagine there is one way to traverse, even to understand what traversal is. I think you just need to just apply it. Okay, so let's just keep that in mind. You have this tree, you have this representation of the tree, because you will understand. Okay, so now let's just imagine that for each node there's a reference, sorry, on the right, there's a reference at the right to the right node, and there's a reference at the left to the left node, and that's exactly how it works for all the nodes. Okay, so let's just put a reference to the right node then to the left node, and I think we shouldn't go really further for this video, because it would allow us to stay really simple for now, but the only thing to remember is that when you arrive at this position at the left node, the left node will be, the left child will be null and the right child will be null, and that's the same for here, here, right child is null, but the left child is null. I just put myself in the shoes of the node, but from here, and that's the same. I don't know if I think you get it, but I just pull from the left, and that's null, here, and that's F. So if that's not very clear, I will just explain again. So the ID of the node is located, we located it at the middle of the node here. Okay, that's one of the way you can use. And so when you're here, you know that if you go on the right, you arrive here. Okay, if you're here, you go on your left, you arrive here. Okay, it references to the data is here. And so I think that's basically what you need to understand about binary trees. We'll go into full details on the different ways to traverse it, and we'll then implement it really, like in JavaScript, for example. We can make an implementation in JavaScript, but I think that's what you need to understand about the binary tree. Okay, and just to clarify why we used those null values is to understand that when you arrive, actually when you traverse tree, what you can do is you can do, okay, I'm at the root node, okay, then I want to go at the left node, I arrive here, then I want to go at the right node, I arrive here, and then you can say, okay, I want to go at the right node, and then you see that it's empty. You see that the object you get is null. So you know that this is a left node, and this will be important. Alright, thank you very much, and see you for the next one.